Welcome back. So now I'm going to continue where we left off in Spark SQL. So I showed you that with Spark SQL, if the data is highly structured in data frames, you can use Spark SQL and Spark transformations. But I also told you that if the data is nested, you can still use Spark SQL, but it becomes a bit more difficult. You need this lateral view, explode, and so on, and the dots for objects. I also showed you that if the data is heterogeneous, then Spark makes it your problem. Basically, it puts everything in a string, and then it's up to you to parse the string again and deal with it. So it means that we need something else to deal with heterogeneity and also better deal with nestedness. So the next two lectures on MongoDB or document stores and then JSONic basically deal with exactly that, with heterogeneous data and highly nested data. So in order to explain the problems, or at least the solutions we have, because people have already been doing things in the past 50 years. If I look at the relational algebra, that's the SQL brush up we did at the beginning, I can manipulate tables, no nestedness, all homogeneous. I can project, select, join, group, sort, and so on, get another table, right? That's the relational algebra. Then I have syntaxes, right? I can use CSV as a means to store tables like that. I think many people prefer to export the content of a database as a SQL script rather than CSV, but that works too. But basically, we have a syntax, and that's the underlying syntax for this model, the relational model. Then we have languages. So in that case, SQL was made to process tables and manipulate tables and output tables. So this is the beautiful world of the relational model, the relational algebra, the relational query languages, and so on. And it works very, very well within that domain if you have homogeneous and data in the first normal form. So for this, we are doing really well. We've already even rebuilt that stack in the case of SQL. You know, we did all of that. Even data frames, if it's not nested, then that's a table. We can use Spark. You saw how you can select, project, join, group, and so on with Spark on the physical level. With HBase, we saw that we can also store the data in a way that looks like table, even though it's not a full-fledged query language, and it's still very physical because all the values are binary values. And then for querying, we can use SQL. People did it. People put SQL on top of HBase. If you look into Hive, for example, you can do data warehousing on top of HBase, right? And we saw also SQL on top of Spark with Spark SQL. So for tables, this is very well known, right? This we know exactly how to do. But the thing is, if the data is nested and or heterogeneous, then we still have a bit of work to do. Here, we are still stuck here, and we need to figure out all of that part in the case that the data is nested heterogeneous. And now you associated, I hope, the idea of nestedness and heterogeneity with XML, JSON, and that whole ecosystem, right? So this is really the idea. Now, when we step into that world of nested / heterogeneous data sets, some things change a little bit compared to the relational world. In the relational world, this is how it works. You have you can parse a CSV file and so on. You have a schema. You need a schema in a relational table. In PostgreSQL, you don't have a choice. You need a schema. Then you have tables that you can manipulate. Now, in the world of nested / heterogeneous data, we also call it semi-structured, you don't have to validate. It's optional. You might remember that, right? You can have JSON or XML that's not validated at all. It's heterogeneous. Then you just short circuit the whole thing, and you can directly query it with XQuery, JSONic, and so on. But you have a choice. You can also validate it if you prefer. And then you end up with a data frame or something like this that is a bit more efficient. Then you can query it. But the idea is that it's faster. That's really a question of speed. This is going to be slower, and this is going to be faster because it's compressed in memory, takes less space. You can optimize a lot of things. For whom is that here? Right? So that's the high level. And we'll see in the technology we are now going to look at MongoDB. We'll see that this is allowed. MongoDB allows you to validate its JSON schema, I think, that it uses. You can specify a JSON schema to validate the data in a collection, but you can do it later. You can just pour the data in your collection without validation, and later you try with a schema, and then you can even enforce it for the future insertions into the collection. Now, whenever you have something like this, and here I put my data engineering hat, you know, that's basically the very early days of that, before MongoDB existed and so on, when the first people noticed that we need something else for nested heterogeneous data set. There is an automatic thought that data engineers have. Before trying to build a system completely from scratch, you should try to see if you cannot exploit existing systems. Maybe you can just reuse PostgreSQL or something in a certain way to tweak it and reuse 90% of it. And then on top of that, you basically have this nested and heterogeneous data. Well, people tried and they failed, but let me show you how. The idea is that you can try to map it to tables, right? So that shouldn't be a surprise to you. If you have a flat JSON like that, then you can map it to a flat relational record. For whom is that clear? Hope for everybody by now, right? The same for XML, right? This is the same. You can map it. So you in some cases, you can map it, right? Then if you have a collection of several, in that case, XML documents, and they have the same schema, then you can put them like this. You can even map the XML schema to a relational schema. Who agrees that this XML schema here would basically map to this PostgreSQL schema, right? The same with JSON. So this is a JSON schema that would map elegantly to this table. So you agree that probably if I have a collection of XML or JSON that looks like this, then I can use PostgreSQL, right? I can just put it like this as it is, and it's just going to work. I just need to map everything to relational schemas and to the relational records. The problem is that it stops working when the data starts having nestedness and heterogeneity. People try to fix it. You can try to fix it. For example, you might have nestedness here, and you notice that you have objects in arrays. So these are what I told you is actually tables in tables in tables. So you could see it as a nested table here. And when you notice that there's still a bit of homogeneity, right here it's nested, but it's homogeneous because it's always the same fields in there. Then if you think a little bit, that you can deal with. You can map it to table. How do you do it? You just do two tables. One table for the top level and one table for the nestedness here. And then you have a foreign key and a primary key. You basically link them via a join to link it back. So Srinivasa Ramanujan and Kurt Gödel, they are linked back to here, and Albert Einstein to this system, right? So you can fix it, but it's a case-by-case basis. You look at this, then you can map it to table. If you're missing fields, so that would be the case of heterogeneity, you can basically just put nulls, right? That's fine. But then you're going to end up with a lot of nulls if you have really heterogeneous data, right? So again, it works up to a certain point, but then you try, and it's impossible to do it in the general case, right? It just doesn't work, and it's like putting a square peg into a round hole, right? So this was unsuccessful, and this is the reason why after trying that, it was decided to invent new systems that can natively process all of these things. We can still use a lot of lessons and practices, but this is why new systems actually appeared, and that includes MongoDB, which we will look into next week, because now it's, I was checking the time, it's almost 10. Yes, that was the appetizer to what we will do next week. We'll look at document stores and MongoDB. So thank you, Marco, for the moderation. Thank you, everybody, for coming. Enjoy the exercise session. If there's anything, ask questions on the Moodle or directly send emails. Thank you for those of you who found typos in the book. I will fix them and add your name to the acknowledgement section. Thank you, and goodbye. Have a good week.